go on and on and on of, all the different, each design requirement. And each one is indicated on its own line, because you're going to go back in and test this later. So you can't have well, it needs to be, in a range of 3 colors, and it needs to have an alarm for this all in one. You do them individually, and this will come in to be important when you're doing your verification and validation activities. Drawings are part of your output. You might have schematics, layouts, circuit diagrams, anything that's going to show how this is going to be built. Some of your outputs may be the component selection. Say we decide we're going to make this out of PMMA. Maybe that's the best thing that won't crack or be brittle. We might select a microprocessor type that's going to go in here. And again, it's an iterative process throughout the design. So you may select something up front, and then as you go along, you may find out you need more memory power, you need more something there. And a very important part is in specifications are the outputs, and those need to already have acceptance criteria at this stage. It could change. That's okay. But you kind of need to have something, a target out there, something you start working with. Now that we have a design and we have the outputs and we have all this documentation, we do a design review. Depending on how complicated your device is, you're going to do this once for sure, maybe 4, 5, 6 times, depending on how many times you go back and make changes to the design. So, documentation is the biggest output here. Making sure that the design goes back and meets up with those input requirements. Is this what the people really wanted, or have we strayed off? Is it capable of meeting that requirements on an ongoing basis? Yes, we can make one of them, but can we make a million of them? The biggest thing in the design review, though, is because it is a mixture of people that are in the design review, and the FDA actually in the regulations spells out you need to have this wide variety of people in the room. You get a lot of perspectives in there, and you start to identify what could go wrong with this design. Okay? And people are looking at it from a manufacturability standpoint, and we're going to look at this even a little bit later, but this is where the flags get thrown up, and no, we can't do that. It's that'll be too heavy, or that'll be too big, or whatever.
Do you look at reliability at this point, at this phase?
I have seen where some people already are starting to look at reliability here, and others not so much, because your design can change, and so then you kind of have to go back and do it again, and I guess that's a little bit of the dilemma with the whole process is you don't want to spend time doing everything over again, but there could be some instances where the reliability at this stage would definitely be of benefit. Since you're going to do several design reviews, you may not include it in the very first one, but then as you have a pretty decent prototype, maybe you get into your beta, I think reliability is a good thing to interject at that point. Design review looks at everything. So if you have accessories to the device, it looks at the components. What are you making this of? Are you going to be able to really get those components? What are some of your requirements on those components? It looks at the software. Is it manufacturable? Can we actually make this device? It looks at labeling. Packaging, especially if you're making sterile devices, comes even more important. It looks at the installation and service, and usually we don't really look that far down the line when we're designing something. You're just going to make it, and somebody else is going to take care of that piece of it. So when you're looking at how are these things going to come back, who is actually going to service them, can they even access what they need to service when it comes back? Are there things that the end user can do? Are there filters that can be replaced, or certain things, or does everything need to come back for maintenance? So it is very, very comprehensive, and in the final design review, that's really where you really dot all your I's, cross your T's. So in this example, we go back in and we look at the actual data that shows, yes, this we get results in 5 seconds. I think I said 2 seconds earlier anyway, 5 seconds. The readout is definitely in milligrams per deciliter. You know, we look at it physically, no sharp edges, nothing that's loose and coming out, seems to be very robust. You see that there's the cables are there for the uploads. If you're going to take the data, put it into a computer program so that it can track your glucose readings over time. Human factors. This is really a whole other topic, so I'm not going to go there very much. But if you're looking at a glucose meter, a lot of them are kind of look like the data sticks anymore. So small, pen-like device. If people are right-handed or left-handed, they're going to hold it, they're going to orient it a particular way. And if you have a digital readout, maybe that's not so good. I'm going to show you an example of that in a little bit. Results are easy to read. It's great. We get them smaller and smaller and smaller, and now they're this big, and then you need some other device to be able to read what's on it because it's so small. Environmental issues are also very important. These would be things that would be in the design requirements. It's going to be exposed to these temperature ranges, these humidity ranges, altitude ranges if it's going to be shipped that way. And again, in the final design review, you are being very comprehensive. Reliability and maintenance come in here, and the manufacturing, installation, servicing. You're really looking at this device from you beginning to make it until it gets to the customer, and perhaps back to you if it's something that needs repair. Next, we go to design verification, and this may seem a little bit out of order, but because these processes are iterative, you're going to do some verification, you're going to do a design review, you're going to do some more verification, you're going to do a design review, so just keep that in mind. This is making sure we're verifying that those outputs, those documents that say the requirements are this, really do go back up and meet the needs of the user, okay, the inputs that we started off with. But going back to our example, we see that through verifying this, the memory does hold 500 readings. Of course, you're going to have to challenge it and try to put in a 501 and see does it respond the way that you have written it up in your requirements. Okay? The components, individual components, meet the specification coming in. This is where you might do a comparison to the predicate device. So you may have a new and improved glucose meter, and in order to get that cleared through the FDA, you're going to have to say, well, it works as well as this other one that's out there. So you might look at that data for that predicate device and verify that you are matching up with whatever the outputs are of that. You're matching up to those results. Measurements in this case, you may have high, medium, low controls. I usually send out a little control sample with the meter so that you can do that check, make sure that it's on target. You might check to see the alarm sounds if the reading is over 140 milligrams per deciliter, or whatever alarm you've decided to do. And then you look at the demonstrations. You're verifying this by looking at some clinical use, home use. You've done some studies where people have played with it. Maybe not necessarily formal clinical trials or anything like that, but just you had some interaction and some feedback at this stage. Then we're going to go into the validation, which everyone is familiar with, no matter what you're working on. And again, objective evidence that it will meet that intended use. So whatever this is really supposed to do, is it able to do it? The thing that's a little different here is that you perform these under the defined operating conditions. So when you're going to validate, if this is portable, handheld blood glucose meter, you're going to validate that with the people who are going to use it. Okay? And you're going to take them units that are coming off of your production line.